My name's Chris Manson-Whitton. I am CEO of a company called Progressive Energy that's been looking to deliver low-carbon energy projects for over 25 years based on CCS and hydrogen and bioenergy, so quite a challenging space to be in. Can I just check, is my presentation somewhere? It is, sorry, okay, my fault, should have done that. So I'm going to pick up, I don't know how many people were here at Patricia's lecture yesterday talking about greenhouse gas reduction and bioenergy with CCS. I thought I would just take a perspective on that. So we've heard a lot about feedstock this morning. I'm going to talk about the other end of the chain if you're actually looking to combine bioenergy with CCS. Because I think, as Patricia said yesterday, there is a view, taking a UK view, that probably 20 to 70 million tonnes per annum of of negative emissions, to use that colloquial term, is required by 2050. And I want to give people in this room at least a vision of how that might actually be possible and how deliverable parts of that is. And I am going to be recognising the fact that actually you guys aren't going to build CCS infrastructure. It's not your job. The fossil industry has a problem and they need to solve it, and they have the money and they need to solve it. They should be the one that put down the infrastructure. What you guys need to know is what's that infrastructure going to look like so that you can work out how the bioenergy system for those more material and large scale negative emissions technologies can happen. Yes, there'll be other negative emissions ways of doing things, but for this. That's my background. Don't worry, I don't have many slides. You sit there go, who's only got the first one up on the screen? So I'm going to tell you about HyNet. So HyNet, for those of you who may or may not be aware, the UK has a policy of industrial decarbonisation clusters and wants to get those away. The UK government has set a sequencing process and has now selected 2 clusters as the first clusters that will get away in the UK. One on the East Coast and one on the West Coast. And that one on the West Coast is HyNet, which we as Progressive Energy conceived of and are developing with a big group of partners to do that. It stretches across the northwest of England and northeast Wales. And it will do 2 things. It will actually produce, distribute, store, and have users of low carbon hydrogen, which will come from a range of resources. But spoiler alert, the heavy lifting initially is going to come from fossil resources with the CO2 captured. And the other leg, which is what's really interesting here today, is the CO2 infrastructure that will lock away and permanently and safely store the CO2. And that will be constructed from a combination of new and some pre-existing assets. So that gives us both economic benefits, but actually also sustainability benefits. We're reusing steel in the ground that is already going to be able to be used for that. So just a little bit more detail as to what HyNet looks like. And I'm actually, for this audience, I'm going to start at the right-hand side or the bottom of the list and then move across. So we are partnered with Eni, who own the offshore fields in Liverpool Bay. So they're gas fields that have come to the end of their economic life. And the idea is they've depleted over time with natural gas. They've shown that they are gas tight, otherwise there would have been no gas in there, and then we were able to fill them back up again with CO2. So that's their part of the system and the pipeline that will then come to the heart of HyNet, shown in red, where we will be sweeping up different users, which I'll show you in a moment, who will be producing CO2 inevitably from what they do and put it into the infrastructure. But then also, importantly, HyNet, the clue's in the name, it includes that hydrogen, which is the hydrogen production, the distribution system, which is shown in blue, which Cadent, the local gas distribution company, will be laying down, storage, and then working with users. And just as a moment, why hydrogen? The reason why hydrogen is going to be important in our energy system is there are only really 3 ways to get energy from one place to another where there are no emissions at a point of use. Either as electricity or potentially as bioenergy, because then you have a biocarbon that's being emitted. The only other way of doing it is a molecule, and the only molecule that doesn't have carbon in it is hydrogen. It will play a role And you can store it. That's the other big thing. We have a huge amount of latency in our fossil system, and hydrogen can replicate that in a way electricity can't easily in a cost-effective way. So it will play a role, lots of different ways it can. Where we are focused in HyNet is on the industrial end. There is almost universal acceptance that there is a role for both CCS and hydrogen in the industrial context. We can debate about many other sectors, but this is a solid place. You can see here those top 3 lines are industrials we are working with who wish to take low-carbon hydrogen to decarbonise, and they are big companies. They have literally signed up to take hydrogen to do what they're doing. One of my colleagues was at Heinz earlier in this week, the largest food manufacturing facility in Europe, in the northwest. They want to run their facility on hydrogen. We ran a trial with Pilkington Glass last year where we ran their entire furnace on hydrogen. We ran a trial with Unilever just this year where the entire Port Sunlight Unilever manufacturing site was fueled for all its steam demand from hydrogen. It is doable. But what is really important along the bottom are users for whom taking CO2 away from their processes is absolutely vital. And again, there are some interesting and well-known names there. I'm now actually going to unpack that a little, because I'm going to say that even when HyNet, which will be operating early facilities in 26, 27, and will be able to tuck away 10 million tonnes of CO2 per annum by 2030, but in the millions of tonnes by the middle of this decade, we are going to have some almost incidental greenhouse gas reduction facilities on that network. Let me talk to you about Padeswood, the cement plant owned by Hanson. You cannot avoid CO2 emissions from making cement. The only way of dealing with it is to capture them. Yes, there is a chunk of fuel that goes into a cement plant, and increasingly that fuel is bioenergy in its content. We'll be taking 800,000 tonnes of CO2 from that plant, of which 300,000 is associated with the fuels that they are using, which are increasingly dominated by bioenergy. Therefore, we will be taking bio-CO2 and storing it. In green, you can see the energy from waste plants in our facility, in our region, of which the biggest is Runcorn's energy from waste facility, Viridor's facility, 1 million tonnes of CO2 per annum, of which approximately 50% of that is bio in origin. So we will be taking 500,000 tonnes of CO2 from their facility. And importantly, they're doing that under an industrial business model. There's nothing about GGR in there. That's an industrial business model. We're getting the GGR almost for free on the basis of an industrial business model. The 2 grey ones are interesting because, again, from the conversation yesterday, and I believe this passionately, that actually our waste resources converting into other vectors are quite important. So we do have a sustainable aviation fuel facility looking to get built in the region. So with Fulcrum. And also, as many of you will know, I've been working with ABSL, used to be APP. We actually have consent for a biofuels facility. That's looking to make bio-SNG, bio-substitute natural gas, to go into the gas network. But actually, if the rest of this goes well, we might as well make hydrogen rather than that. But in that process, whichever one, CO2 is rejected inevitably as part of the process. We can capture it and put it in. And then the final 2 I'll pick up. There is a small biomass power facility in the region that is looking to see if they can connect. And rather interestingly, we have a bio-CO2 aggregation project in development. If I wish to use anaerobic digestion to make biogas and then biomethane, I have to separate CO2 out. It's part of my business, it's what I do. That CO2 is very suitable for onward transport and storage. So what we're looking to do is to aggregate from a number of those smaller facilities, and this is a smaller part of the overall story, but maybe up to 250,000 tonnes from a number of facilities being aggregated with a liquid tanker system that will bring that to the main infrastructure that can then store that CO2 as well. So I guess what I want to say is there's a number of just final points, really. Why is GGR based on bioresources with CO sequestration so interesting? I think the first one is that to put robust monitoring, reporting and verification is relatively straightforward. We are literally metering the CO2. It goes through a meter and we are bound by government to ensure that it stays there and that we monitor that it is staying there permanently. Compared with DAX, it is a lot easier to capture something from 5% up to, in some cases, 40% partial pressure of CO2 than it is from the atmosphere. As I think I've hopefully said, some of those processes already have to separate CO2 from the main product for their own business, so that reduces the cost and any additional energy penalty. And in many cases, we are not relying on new technology. The separation technologies already exist. As again I've indicated, some of those cases, the business models for it are under either highly developed or almost there in terms of business models for industrial carbon capture in particular. Yes, we are expecting a GGR business model too, or let's call it a BECCS. Just a reminder, BECCS, bioenergy with CCS, not necessarily just bioelectricity with CCS, so bioenergy with CCS, but it doesn't rely on that in many cases. And I do think the voluntary offset market is going to play quite a role in getting some of these projects away. For example, that bioaggregation one, the bio-CO2 aggregation, could well actually find that is the best way to get that project away because that market is moving and the private sector values monitorable, reportable, verifiable CO2 emissions that are negative. So, government has an objective of 5 million tonnes of GGR by 2030. I would actually say, look, I'm looking at 2 million just from one area alone. I don't think it's incredible. And then if you take that and say, well, maybe you need to get to 20 or 70 by 2050, actually, you know, I think it's doable. We lay down that infrastructure. I've given you some ideas of what can connect into it. If other bioenergy facilities or bioconversion wishes to connect to this kind of infrastructure, it will get built in the Northwest and the East Coast and in a number of other clusters across the country as well. So all I wanted to do, inspire you, there are those opportunities. If you want to learn a bit more about the infrastructure, there's the HyNet website as well. And again, I'm really sorry, particularly to my fellow panelists, because I'm about to say thank you so much. I'll grab my bag and go, but I hope that the rest of the conference goes well today. Thank you.
Okay, thank you for that, Chris. The perils of running over time. So can I just remind all our presenters today, you have been allocated a time slot. If we can stick to it, then we can actually have more fruitful discussions with our panellists at the end. But the next person that I have today is Sarah Davidson from Croda. We wanted this session to give us some different industry perspectives. So we actually have 3 very different types of industry here and also 3 different scales. So over to you, Sarah. You've got your 10 minutes.
I've got my 10 minutes. Brilliant. Okay. So hi, everyone. Thank you very much for having me today. As Patricia said, it's quite a different talk that I'm going to give now. So for those that aren't familiar with Croda, we're a specialty chemicals manufacturer. So we're a B2B company. We buy bulk chemical raw materials off many organisations that I imagine some people in this room supply to, so BASF, Cargill's, INEOS, and then we sell to often consumer-type companies, Unilever, L'Oreal. So our products end up in a whole range of different products that you will most likely use on a day-to-day basis. So a lot of our business is made up of beauty care products, so surfactants that go into shampoos, soaps, fabric conditioners, all those types of things. But we also have a life sciences business where we sell into pharmaceuticals, so we sell vaccine adjuvants, and our biggest kind of success that I always have to mention whenever I do a presentation is that we actually sold a vaccine adjuvant that went into the Pfizer vaccine, so that's something that we're all very proud of at Croda. So if anyone in the room has had the Pfizer vaccine, then you've got a little bit of a Croda molecule inside you. So in the presentation today, I'm going to talk a little bit about our approach to biomass, so thinking within the realms of us as a chemical company. But I'm also going to talk a bit more about some of the challenges with using biomass. As talking to Patricia and Joanna before, I think these transcend different industries, different markets. So that's where I'll spend most of my time today. So as a bit of background to start with, sustainability really is at the heart of our business at Croda. And we've gone as far as launching a commitment for 2030 to be the most sustainable supplier of innovative ingredients, helping solve some of the world's biggest challenges. And to do that, we've decided that we're going to be climate, land and people positive. So having a positive effect on the world, the people and communities in which we operate in, and also land. So through our agricultural business, but also in the land and biomass and resources that we use. And we've aligned ourselves with the UN SDGs. So there's a few that we've picked out as specific priority for us. And these are the ones we think we can have a most positive impact on through our business. So a key part of our commitment for 2030 is our target around bio-based content. So we've set quite an ambitious goal for 75% of our organic raw materials to be bio-based by 2030. So just to give you a bit of context to that, this is a picture of the rest of kind of the chemicals industry. So 2020 data from the RCI, or Renewable Carbon Initiative, showed that around 10% was bio-based, 5% was recycled, so 15% on average was renewable carbon. And Cefic, so the European Chemicals Association, showed that by 2030, they want us to get to 20%. If you then map our 75% target onto that, you can see that we're quite a lot higher than the average for the chemical industry. So this is something that we're really, really storming ahead with. You can see over the past few years, we have increased quite steadily in our renewable carbon content. So we really need to keep doing that if we're going to get to our 75% target. So I'm sure you're very familiar, but when we're talking about renewable carbon, we can split this up into three main types. And this picture was actually taken from a Cefic paper that I've referenced on the slide there. So we can talk about carbon that's been captured from the atmosphere and turned into useful feedstocks, as kind of was mentioned previously. We can also look at recycled materials, so polymers and plastics that have been broken down back into monomers and then repurposed into different feedstocks. Oops. And then obviously we can talk about bio-based materials. So we've specifically decided to target bio-based materials because it can enable us to get to carbon negative products. So not only having the carbon storage through the use of those bio-based materials, but then when we factor that into our cradle to gate footprint, we can offer our customers a lower carbon footprint product, which is something that they're all striving to do. But there are quite a lot of challenges with this target. So as a bit of an introduction to my role, where I sit within Croda is in our research and development team. So I actually look at sustainability within R&D, how we can use more sustainable feedstocks to make more sustainable products. And part of that means I'm out there always searching for these new raw materials and try to convince the rest of the business and our research teams to use them in new product development. And this is where I often come across quite a lot of these challenges. And I'm going to talk about each of these in turn and, depending on time, run through a couple of case studies. So the first one is the potential increase in cost. Now, some of our key suppliers have started moving to bio-based equivalents, which is brilliant. But when we're looking at the scale and abundance of these materials that we need, they're not always there, meaning that there's a premium often with going to a bio-based equivalent. And this is something that we're going to have to battle with when we've got the likes of L'Oreal coming to us and asking for natural bio-based materials, but not necessarily wanting to pay for more expensive products. So that's something, you know, we've got to try and factor in. The other and probably most important thing for me is that bio-based doesn't actually always mean sustainable. And I think this is one of the biggest misconceptions. So you could take a biomaterial that's come from somewhere that's been deforested to grow that material. There's been slave labour involved. There's been some crazy, horrible chemical synthesis to get to that material that's incredibly toxic. We don't always mean sustainable bio-based. So a lot of the stuff that I do is to go through life cycle assessments and understand the true sustainability impact of those materials, so we're not just transferring the impact to somewhere else. The other problem for us when we're looking at this as a big corporation is that sequestered carbon doesn't actually count to our science-based targets, which is something that's quite interesting. So when we're going to the rest of the business and trying to say, let's move to these bio-based raw materials, we can have lower carbon footprints. Actually, when we look at our organisational footprint, we can't count the sequestered carbon from those biomaterials as part of our Scope 3 reduction. So this then means it's quite hard when we're looking at transferring bulk of a large mass of our raw material over to bio-based, as well as having that economic impact. We can't often count the positive sustainability impact there. The next point I wanted to touch on is that it's often difficult obtaining like-for-like chemistries. So there are some quite obvious examples where we can get bio-based options that are identical to petrochemical. So ethanol, I think, is the easiest example for us to think about. But in many cases, there aren't those like-for-likes. So if you think about us as a research and development team, there's a lot of time and effort that needs to go into redesigning products, often using a different chemistry or a different set of initial molecules to get to the same endpoint, if we want to still deliver some of those high-performing products that our customers are buying, but from a bio-derived origin. And that brings me on to my final point, so the impact of changing raw materials further down the supply chain. So as I mentioned earlier in the presentation, we do sell into the pharmaceutical industry, which is heavily regulated. So this means any change we make to our processes or raw materials, we have to inform them. And this could actually affect the drug master file and the type of impurities that are in there, and potentially cause them a lot of headache when it gets to the registration of their products and potential re-registration if there's any change. So essentially, they do not want to change a thing. So even if we've got a bio-based feedstock, which, you know, we've battled with all the other issues, we've managed to make it cost effective, we've proved that it's actually from a sustainable source, it's a lower carbon footprint, just because it's different means that it's really hard to push through for some of our customers. So I'm not painting a very good picture. This all sounds like there's a lot of work to do, but actually there are some real positive cases that we can pull out. So the first one that I wanted to talk about is palm oil. So the reason that I've decided to talk about palm is I think it gets quite a bad rep, but it's a material that we keep going back to within the chemicals industry because it is quite an efficient producer of oil. So if you can see the chart on there, you can see where palm oil sits in terms of the oil you can get per hectare of land. It's significantly more efficient than other sources. So if the land is able to be managed effectively and sustainably, then we can get quite a lot more from that feedstock than some of those other options. But what we wanted to do, because of the kind of negative association with palm, is to make sure that all of the palm that we are sourcing is actually from a sustainable source. So now what we've done is we've ensured that 99% of our Europe and America's palm is from RSPO, which is Roundtable for Sustainable Palm Oil. So certifying that that is actually from a sustainable source. Our goal is to get to 100%, so we've just got that 1% to go. And we've also worked with Action for Sustainable Derivatives to do full supply chain mapping of 97%. Again, we want to get this to 100% so we can really ensure that this is coming from a sustainable place, and we've got that visibility right up the supply chain. But one of the things I wanted to mention was actually the knock-on positive impact that we found with greenhouse gas emissions. So we did expect there to be a positive impact when it came to biodiversity impact through moving to the sustainable sourced palm due to better land management and more sustainable farming practices. And we did an LCA to try and look at the impact of that. And what we found was that, yes, there was an improvement in biodiversity impact, but we also found that there was a positive impact in terms of greenhouse gas emissions. And again, this actually came from the more sustainable farming practices taken on by the farmers that were getting this RSPO certification. And what we found last year was that we saved nearly 24,000 tonnes of carbon dioxide equivalents by moving to sustainable palm. So this wasn't our initial purpose by going to RSPO. It was more about the biodiversity impact and sustainable supply chain, but it was a positive that we also found came out of that move. very quickly, one thing I also wanted to touch on very briefly was that a lot of the time we talk about decarbonisation of feedstocks. And as I showed in the previous example, this was the case, moving to a sustainable source. But actually, we don't want to completely remove carbon. What we often need to talk about instead is defossilization. We still need those carbon atoms that exist in those raw material feedstocks to make up our chemicals. They just wouldn't work. They wouldn't be what they are without those carbon atoms. So I think it's actually better when we're within the chemical industry to talk about defossilization of our products rather than decarbonisation. So one thing that we've actually done is moved from ethylene oxide from petrochemical sources to biomass sources. So I went over to our site in the US where we're doing this. We're getting ethanol from a corn-based source, turning that into bioethanol, bioethylene, and then bioethylene oxide. So you can see this is an example of one of our surfactant products, which started off at 11% bio-based. But just like magic, through changing our feedstock, changing that supply chain that we're coming from, we can move that to 100% bio-based, which obviously introduces us to a whole new market when it comes to those customers that only want to get from natural bio-based products. But one thing that we're now looking to do to go one step further than that is to look at truly bio-based routes. So biotechnology is something we're looking at in order to transform those bio-based feedstocks into our end products. And the last point I wanted to finish on was just an example of the impact on product carbon footprint. So as well as seeking products that are from a bio-based source, customers are now looking more closely at that product carbon footprint that is delivered with the end product. So this, you can see, is kind of a bit of a life cycle of one of our products. We started off in 2018 around 2.5 kilos of CO2 per kilo of product for this particular product, and through the move to bio-based materials we were able to reduce that by around 12%, and this is coming from the sequestered carbon of that bio-based feedstock and then taking that off the end product carbon footprint. But we've also set goals to look at decarbonisation of our manufacturing sites. So here we're talking about energy, so I can say decarbonisation. So we're looking at moving to more renewable sources of energy, electricity, for example. We've got turbines, solar powers, and through the move to 2030, we expect to see a decrease of 23%. Then lastly, we want to scale up our production. So at the moment, we're not running at full scale. We've got a few bottlenecks in the process. So we're hoping that that will take us further in terms of our reduction. And we're also looking at opportunities for sugarcane feedstocks rather than corn, which we're using at the moment. So overall, we hope to see a reduction of 71%, taking us to a final footprint of 1.8 from 2.5. So you can see that not only can we go to bio-based feedstocks as a way to reduce our product carbon footprint, but taking in some of the things we've mentioned earlier about renewable energy sources as well, we can further reduce our footprint. But one thing to note here is that we also need to consider the end, so the final fate of our product. And in this case, this particular product is going into crop applications where biodegradation is particularly important. So if we consider where that feedstock has come from biomass, from plants, going back into the soil, degrading down into CO2, coming back out, and it can enter that circular system again and then be resequestered and go so on and so on with the cycle. So what does the future look like? I touched on some of the challenges and some of the things that we're doing at Croda, but what we've seen is we can't do this by ourselves. We really need to have collaboration across the supply chains, information from our suppliers on where feedstocks are coming from, which we can then pass on to customers, understand the use of our products and the end-of-life fate to better design in sustainability from the start. And also within industry. So as I put there, one man's waste is another's treasure. So we can actually look at different waste materials, different potential new feedstocks that could be more sustainable too. Better data. So as I said earlier, I'm trying to look at data all the time to understand what is the most sustainable option. And there's no way we can do that without getting that information. Next up is consumer education. So as we talked previously about farmer education and the societies in which some of the forests and woods are being put, we need to educate the consumers on what is and isn't a sustainable choice. So I've seen data out there that looks at carbon capture and then putting that into shampoos, for example, and asking consumers what they think about it. And they thought, no, that's awful, that's really dirty. I'm not using carbon dioxide, but actually it could be a much more sustainable option. It's just they don't get that yet. So there's a lot more we need to do to educate consumers. And then the last one, and probably the biggest one, which I've pretty much not talked about at all, is actually the policy and regulatory instruments. So promotion of taxation to drive the adoption of renewables. So we see in the UK Fuels Directive, which is driving more renewables into the fuel sector, but we've not really considered what that means for other sectors such as chemicals, where there could be instances where it's more sustainable or potentially more economic to use certain biofeedstocks in chemicals as opposed to fuels or other industries too. So I feel like I've really sped through that. I'll be here for the rest of the day if you want to pick up on anything in a bit more detail. But hopefully you've seen that there are different forms of renewable carbon we can use. We're really focusing on bio-based because of the opportunity to reduce product carbon footprints. But we need to be mindful of the particular challenges in terms of making sure they're actually sustainable and dealing with customer and industry pressures as well. And if you want to get in contact with me, you've got information here. We've also got our own dedicated email address where we're looking for any opportunities for new bio-based feedstocks. So if you're sat there thinking, I've got something that I think would be pretty useful to you, then please fire it over to our biobased.feedstocks@croda.com email address. And then hopefully we can pick that up after. So thank you very much, everyone.
Thank you, Sarah. Brilliant presentation done at super speed. Alan Douglas from KEW Technologies is... I haven't met you, Alan. I know many of your colleagues. You were a last-minute substitute, so I was looking around thinking, what does he actually look like, I'm afraid? So you're going to give KEW Technologies perspective. Yes. Thank you.
Thank you. Morning, everybody. For those of you who don't know who KEW Technology is and what we do, I would say KEW is the glue in the biomass to energy chain. We're the partner, and by that I mean a biosensitive glue, not anything derived from anything else. We are the company, our technology is the technology that allows biomass to be converted into energy products. It could be a basic energy product such as heat and power, or it could be a nice advanced energy product, a syngas that we can use in industry to replace natural gas. It could be a product called RDME. The R is renewable or recycled carbon fuel, and for those of you who don't know, DME is dimethyl ether, and it's a replacement for LPG. So it's a way of defossilizing, decarbonising off-grid energy, where they're not connected to the gas grid, they're not connected to the electricity grid. What can they do to decarbonise? We can produce a low-carbon diesel, and by the end of next year, we'll be able to convert waste biomass into hydrogen with carbon capture that then go into the high net pipe in 10 years' time when they've built it. So I've been asked to spend a few minutes today talking about what the opportunities are for us and what the threats are. So in terms of the opportunities for us, really they're limitless. KEW's advanced conversion technology can process a wide range of biomass, biogenic rich sources. It could be waste, RDF, your black bag waste from home. It could be waste wood. It could be energy crops. It could be all sorts of things, sewage sludge, chicken litter, anything that has a biogenic content. We can convert that through a process of gasification into a hydrogen-rich synthetic gas. Because our technology, our IP, will enable us to convert that from the very variable syngas you get coming out of gasification processes into a constant chemical content syngas, we can then turn that into a wide range of energy vectors. So KEW sits between the biomass, the biogenic producers on the one hand, it comes through KEW, and then we can look at two broad addressable markets. One is industrial companies, the other is the fuels businesses. within the industrial companies, what we look at there is what can we do on their site? Our technology is very small scale. You could fit 2 of our units in the footprint of this room. That would be enough to process 40,000 tonnes of biogenic waste a year. Now, because we can do that, we can take someone, and Chris mentioned Pilkington doing a hydrogen trial. We're also working with Pilkington. They're a very forward-looking company. They're always looking at different opportunities. We are looking to install a number of our units on one of their sites. They've got a small bit of wasteland they're not using. That will enable them to switch 40% of their natural gas use to a synthetic gas. If we derive that synthetic gas from waste wood, that will reduce the proportion of those emissions by more than 100%. It's those sorts of things that we're looking at on the industrial side. We can work with steel mills, glass, pulp and paper is a great one. We can use pulp or waste as a biogenic feedstock for our process. So all of these, anything biogenic, and we can convert and help defossilise a wide range of industries, a wide range of transport fuels. So the opportunities for us and what we do and what we can do are actually limitless. It's quite an easy proposition at the moment. Do you want to decarbonise your energy? Tick, yes. Do you want to fix your energy costs? Tick, yes. And do you want to save money? Tick, yes. There have been harder things to sell in my life than a defossilised, fixed-price, low-cost energy solution that we have at the minute. But, you know, life isn't rosy. It's not as easy as I would have you believe by that previous statement. It's not a level playing field out there. Government policy, and I recognise that there may be people from government here, so this is not addressed at you personally, please. It's more against your political overlords, and will you get them to talk to each other? Some carbon energy replacement products are heavily subsidised. SAF is heavily subsidised. Hydrogen, interestingly, is heavily subsidised if you're using it in transport, but not at all if you're using it in industry. You can take the same waste, the same biomass, convert it into the same energy product, but if you put it over there rather than over there, one side gets a big subsidy, the other side gets nothing. I don't know why. There's no help if we're trying to decarbonise the chemical sector, for example. There's nothing at all for that. So what government hasn't yet done is take a big step back and go, what's the best way of defossilising the UK economy? BEIS reckon that the best way to go about it is defossilising industry and with carbon capture. Department for Transport reckon it's using those same wastes, those same biogenic feedstocks for SAF and hydrogen for transport. But they're not, to the outside world, it's not clear that they're talking to each other and looking at the wider picture for UK PLC and the greenhouse gas emissions and how best to apply the country's biogenic resources to maximise the defossilisation across the economy. Government also, and this is politicians, like to cut ribbons on massive projects because that looks like they're doing something real. As I said, KEW's technology is quite small scale. We would rather install 100 units in 30 or 40 different locations than have one massive project. Small steps, small incremental steps are the way to succeed. It's not about waiting 10 years for a hero project to come along to be the panacea and the answer to everything. It's small steps, small projects, one here, one there, 2 over here, 2 over there. That's the way to deliver it and to deliver it sustainably. On the regulatory side, it's inconsistent there again. What we're doing, and it was mentioned in the Croda presentation in terms of different sectors look at sustainability differently. We're dealing with government, but government doesn't look at sustainability the same way. You can look at one subsidy scheme, you have one system for assessing sustainability. You look at a different scheme, you have a different set of factors to assess whether you're a sustainable process. And that might be great if you're using different technologies, But Q's basic technology is the same waste, the same biomass gasification unit, but depending on what product we're selling into which market, we might have to have 5 or 6 different sustainability calculations for the same process, for the same product, from the same materials. It makes absolutely no sense whatsoever. And so there is a great future out there. There's some joining up needs to be done. And one thing not mentioned on here, but because of earlier presentations in terms of biomass and energy crops, one of the issues that we have as a project developer with our industrial clients of relying on energy crops is trying to match up the timelines. If an energy crop takes 3 or 4 years to build or to grow to when you can start harvesting, we can have our units installed in 12 months. What are we going to do for those first 3 years while we're waiting for the energy crop to grow? Energy crops are also a very diversely supplied sector. If I want waste for a project, I can go to one company, I can get 200,000 tonnes of waste every year from that company reliably and dependably. I can't go to one farmer for 200,000 tonnes of energy crops. I need to scour the whole of Yorkshire, for example, multiple farmers who might decide to change their crop growth or what have you. It's a much more complicated supply chain to put in place. And that's the challenge the energy sector has for using energy crops as a source of the energy that we want to use. So I appreciate this has been a very quick canter through. I've tried to stick to my 10 minutes and to keep you from your coffee for no longer than absolutely necessary. But Q is there. We're working on these defossilization solutions. We have a technology. It operates. It generates electricity and heat. By the end of next year, we'll be making diesel. We should be making DME as well, all from waste biomass sources. The future is really, really bright, but there's a few hurdles we have to get over before we get there. If you want to find out more from us, there we are, info@kew-tech.com. For those of you who are going, and I'm sure there'll be lots of you, we'll be at RWM next week at the NEC. Come and see us there. I'll be there both days. I'm happy to answer questions then. As we've overrun, I do also need to have to run away because I have a meeting with Bays at noon on the project we're doing with Pilkington. But come and see us at RWM or email me questions on that info@kew-tech.com and we're happy to help out. Thank you very much.
Thank you, Alan. It is a pity that we are running over time. I'm sure there are people who would have responded to some of those things, but I think fair to say that we do have a policy perspective session later, and we've got a full session on that tomorrow morning, actually. So many of the things that you raised are actually being dealt with, and I think that we will come through with that. And we do talk to your colleagues, particularly Amna and Mark, on a regular basis about that. So, okay.